Hello, so today I'm looking at M3 International A Level January 2017. This is question 4. So I have this diagram and this explanation beneath. A light inextensible string has its ends attached to two fixed points A and B. The point A is vertically above B and AB is 7 little a. A particle P of mass m is fixed to the string and moves with constant angular speed omega in a horizontal circle of radius 4a. The centre of the circle is C, where C lies on AB, and AC is 3a, as shown in figure 3. Both parts of the string are taut. Show that the tension in AP is this. And then afterwards I'm asked to find the tension in BP, and then afterwards deduce that omega is bigger than or equal to this. Okay, so if we begin by just drawing a diagram of what forces are acting on P, then I have P here, I have the weight down, mg, and then I have these two different tensions here and here. I know that this, I'll call this TAP and TBP. Then I need to know the angles that these are acting at. So if I just draw on a dotted line here, so I'll call this angle theta, and I can see from this triangle this would be theta here. So I can see tan theta is 3a over 4a, and the a's will cancel, so that means that sine theta will be 3/5 and cos theta will be 4/5. Now for the other string, in the other string I've got 4a and 4a, so this is an isosceles, and if that's 90, then each of these two angles here would add up to 90, so they will be 45 each. So I know that this angle here is 45 degrees. Okay, I also know that this particle is accelerating towards the centre of the circle, and the radius of that circle is 4a. Now, and later on in the question they talk about omega. So when you're using the acceleration towards the centre of the circle, you're either using v squared over r or r omega squared. And in this case I'm going to use r omega squared because omega squared is mentioned later on in the question. So the acceleration towards the centre of the circle is the radius, which is 4a times omega squared. And then I can see that in this tension is written in terms of A, omega, and M, and G. So I need to eliminate these two tensions. Okay, so now I can begin by resolving vertically. And vertically it's not accelerating, so forces up equal forces down. So I have TAP sine theta, which will be 3/5, but I'll put that in later, will be equal to mg plus TBP multiplied by sine or cos, it doesn't matter, of 45 degrees. So sine of theta was 3/5, so I can pop that in here. So I have 3 TAP over 5 is mg plus root 2 over 2 TBP. Okay, then resolving towards the centre of the circle instead. In this direction it's accelerating, so I have TAP cos theta plus TBP cos 45 equals the mass, which is m, multiplied by the acceleration, which was this. Okay, now because I'm looking for the tension TAP, then I need to try to get rid of TBP, and I know, oh actually sorry, I'll just tidy this up a bit first. So here I have TAP cos theta, and cos theta was 4/5, So I've got 4 TAP over 5 plus root 2 over 2 TBP is 4MA omega squared. So I'll call that 1, I'll call that 2. So basically, if I rearrange this one to give me T, or root 2 over 2 TBP, then I can substitute in 3 TAP over 5 minus mg in the place of this bit here. So I would get 4/5 TAP plus 3 TAP over 5 minus mg would equal 4MA omega squared. If I just look back at what I'm trying to find TAP, I think. Yeah, okay, so I'm looking for this. So if I move the mg onto the right hand side, so add mg to both sides, then I get mg plus 4MA omega squared. If I do 4/5 of TAP plus 3/5 of TAP, then I get TAP multiplied by 7/5. And so therefore the tension that I'm looking for is 5/7 of this. And then I'll just check with the question, see how that compares. 5/7, and yes, I have the same thing. So they took a common factor of m out, but I do in fact get exactly the same thing. So I'll just rewrite it exactly as they did. 5/7m, and then they wrote this bit first, so 4a omega squared plus g as required. Okay, so that part of the question is worth 8 marks, and the next part of the question is to find BP. So now I will use one of the equations that I had up here to find what BP is. So perhaps if I use the first equation, it looks a little bit nicer. The first equation was this, so I need 3/5 of the expression that I just got, which was this thing, 5/7 m 4a omega squared plus g. So that is the left hand side, equals mg plus root 2 over 2 TBP, and I'm trying to find TBP. So here, these different cancel. So I'm just going to multiply this out a second, because then I need these mg to come over here as well. So I'm going to have 3 times 4, so I have 12 MA omega squared over 7 plus 3 mg over 7, and then I would have minus 1 mg, which is 7 mg over 7, equals root 2 over 2 multiplied by TBP. Now to get rid of this, I would multiply both sides by 2 over root 2. And now I just need to tidy this up a little bit. Okay, 2 divided by root 2 is root 2. And then here I've got a common factor of 7 on the bottom and m on the top. Then I end up with 12, the m went there, the a is here, the omega squared is here, the 7 went there, and here overall I end up with 3mg minus 7mg, which is 4mg over 7. So minus 4, the m is there, so here I just need to write a g. Okay, I could leave it like that, or I can take a factor of 4 out. That would make it a tiny bit nicer. So here I would get 3a omega squared minus g is the other tension. So that was worth 2 marks. And now in part C, it says deduce that omega is bigger than or equal to this thing, stating the value of k. So how can I get an inequality with omega in it? Well, I've got this expression for omega, and I've got this expression for omega, with an omega in it. So I know that out of the two of these, if this is not going fast enough, so if this is not rotating fast enough, then the string will go slack. Which string? Well, this string will always remain in tension because it's got the weight acting downwards, so there will always be a tension upwards. But the risk is that this tension could go to 0, so because this string could potentially become slack if it's not rotating fast enough. So the limiting factor for omega is going to depend on this, the tension here. So if I go back to my expression that I have for that tension, and for that horizontal circle to kind of stay in place, I need the tension in that part of the string to be bigger than or equal to 0. So therefore I need this thing to be bigger than or equal to 0. So if I divide both sides by 4 root 2, times them both by 7 and divide them both by m, all of these are positive, so they have no effect on the inequality sign. So now if I add g to both sides and divide both sides by 3a, then I get g over 3a will be less than omega squared, and they wanted omega, so now I just need to square root both sides and just take the positive root. And so now I can see the value of k, so k must be 3. So it's already clear from what I've written there, but if I'm being kind to the examiner, then I'll write that explicitly there so it's a bit easier for the examiner to find. Okay, so that part of the question was worth 2 marks as well. So altogether you have 8 plus 2 plus 2, so 12 marks for that question. So I hope you found this solution helpful. Do click like if you liked it, and good luck with your revision.